Air pollution and climate change are the main concerns of the present world. Millions of deaths and public health hazards are attributed to poor air quality. Global temperature increase causes more frequent natural disasters such as drought, wildfires, and hurricanes. The energy sector is considered as the main cause of the problems, with emissions from fossil fuel combustion such as carbon dioxide, sulfur oxides, nitrogen oxides, and particulate matter. As energy sectors around the globe suffer a beating caused by COVID-19, developing the use of LNG can aid our progress towards green recovery. The two main issues are the management of boil-off gas, or BOG, in the LNG fuel tank, which is mainly due to the heat ingress from the environment, and safety. There is thus the need to limit the pressure increase inside the LNG fuel tank without releasing the BOG into the atmosphere. Pressurized tanks are often preferred owing to the ability to withstand high pressure, affordance of easy BOG management, and need for minimal maintenance. The two BOG management options are as follows. 1. Extraction of BOG using a compressor from a low-pressure LNG fuel tank. 2. Self-containment of the BOG at the expense of pressure increase with a high-pressure LNG fuel tank. The cost of the compression package is the main cost implication of the first option, while the high-pressure LNG fuel tank is a major cost component of the second option. The second option is not economically attractive for tanks with capacities greater than 1,000 cubic meters, owing to the high cost of the required high-performance installation such as vacuum installation. The use of compressors is thus preferred for BOG management in large LNG fuel tanks. Safety is also an important technical challenge. Loading the fuel tank with LNG is completely different from the HFO loading due to the fuel characteristics. One difference is that LNG is stored as boiling liquid, which means that an accurate analysis of thermodynamic state of LNG is required to prevent the overpressure of the fuel tank. A second difference is that LNG is a cryogenic liquid at temperatures of about negative 162 degrees Celsius. It is hazardous when it comes into contact with conventional steel structures or piping and personnel. It is important to note that LNG is a promising alternative fuel to meet the rising energy demands. It can reduce CO2 emissions by about 20% as well as other greenhouse gases. However, LNG is harder to treat than conventional fuel due to its low flash point. Therefore, we should improve the technologies and regulations to utilize LNG as safer, sustainable, and economical fuel as we continue to promote the green recovery.